Hello and welcome. Good morning, good evening, good afternoon, and thank you for joining to another Neo4j live stream with a special guest today, Sebastian Müller from yworks. Hi, Sebastian. How are you doing?
Hi, Alex. Thank you very much. Thank you for having me. I'm so much looking forward to being on the show and showing you what we've been working on in a couple of months, even years, maybe even decades. So there's a lot to tell today. So let's see.
That sounds good. That sounds like a lot of content. That's going to be fun. We'll enjoy. I'm very much looking forward to it as well. I mean, I know and I like yworks and what you do. So I looked at it a couple of times. So it's a cool tool. So I'm really excited and maybe we can go about it a little bit later on. But before we dive in, I wanted to say obviously one thing I have to say at the moment is Notes 2022 is coming up. So I want to quickly take the opportunity and say registration is open. Register now. I'll put the link in chat. So if you are interested in a graph related topics, and I guess you are when you're watching this, then Notes is going to be the event taking place later this year in November. So we will talk about the agenda and about all the good stuff in a few weeks' time. But for now, you can already register, put the date, save the date in your calendar. It's 16th and 17th November, and yeah, we're all looking forward to it. I guess yeah, that's what I wanted to say on Notes. So yeah.
I hope I'm going to be there too. I submitted a talk, so I'm keeping my fingers crossed so that it'll be accepted.
Hopefully, I don't know. I have no actual insights, and I cannot influence. I must not influence, but maybe.
Maybe.
Yeah.
Cool.
All right, but let's go to today's topic. It's called Easy Graph Visualizations for Data Scientists with yworks. Maybe before we talk about this, Sebastian, why don't you say a few words who you are, what you do, and maybe also how did you discover graphs? What was your first touch point with graphs and Neo4j?
Yeah, sure. Thanks. Yeah, that's actually quite a long time ago. So that's where the decade factor comes in. So I've been CTO of yworks, which is the diagramming company. We call ourselves the diagramming experts for 10 years now, but I've been part of the company for almost 20 years. And the company was established in 2000, and we were basically, we're a spin-off of the University of Tübingen. And so in the late 1990s, I actually started working with graphs from the graph theoretical point of view. And we've been looking at graph visualization, mostly automatic layout, not so much graph databases. At that time, I don't think I knew what a graph database is, and I think there was no Neo4j at that time.
No, yeah, that was before the time.
But so we've been in the business working on the visualization, on the interactive part, so making graph visualization accessible to users, and enabling software developers to create great visualizations and add them to their applications. And so over the years, I read about this. Well, I followed the graph world. Obviously, I had to, and I think I got aware of Neo4j pretty early, and but we really got into contact with it. I think it was somewhere around 2015 when the first customers approached us and they told us, well, we want to use Neo4j together with your tools, and that's how we decided, well, there's something in it for us too. So let's look at what they have to offer. And then we went to, I think my first conference was Connected Data in London 2015 or 16, I don't know.
Maybe, yeah, there was could be.
Yeah, I think that was my real contact with the Neo4j world, basically. And we at that time, Neo4j was all about storing the graph. So today there's lots of things have changed and happened, and there's visualization, Bloom, and so on. And at that time, we really thought, okay, that would be a perfect match for us to jump in and basically help our customers with bringing together graphs in the Graph database, Neo4j database, together with our visualization technology. And then we built some tools around it. And some of these, or at least the successes of them, I'm going to show you in a minute. But that's basically how I got into graphs and into Neo4j. So yeah, so this is my story.
That's cool. Yeah, that's a long time ago. I remember. I think you were, because I'm a little bit fresher to the whole graph world. Not as fresh as some others, but still not 20 years like yourself. But I think I remember the first time we met was at the I want to say a graph tour, maybe in London at some point, maybe 2017 or something. Could be that. Could that be maybe?
Yeah, I think there was another Graph Connect, and then we went
Graph
also
Connect. Yeah, maybe it was a Graph
and
Connect.
we went to New York, and then Berlin. Yeah, we've been to quite a number of meetings. So if you've been there, you might have met me or some of my colleagues or all the audience. Yeah, so it's cool. It's nice to see how the product develops and then what new stuff is being created on top of it. So really exciting times to be in the graph world.
Absolutely.
I actually prepared a slide. So if you want to share it, I can quickly show the audience what this all is about. So I some of this I already said. So I'm CTO of yworks, small company, 35 employees, and we've been working or dedicating all of our time to diagramming, basically to the visualization aspect of graphs and diagrams. And what we do is we create one software. It's a software development kit for software developers. It's called yFiles, and you can do all kinds of crazy stuff with it. Among of this, we've built some tools ourselves with our own tools, and these are the tools that we'll be looking at today. And most importantly, the yFiles Graphs for Jupyter plugin, which is a plugin for graph data scientists to use in the context of Jupyter Labs and Jupyter Notebooks. And these are free tools, so everyone can just go and play with them or install them. So if you, in the case of Jupyter Graphs, you can just do a pip install and get this and get running. So all of these tools in that row are actually, in that column are actually free tools, and they support the connection of Neo4j to Neo4j databases, and that's why I'm here. So not all of them are specifically made for Neo4j. The DataExplorer is. The other ones have great support for Neo4j, and I'm going to show that to you. And specifically, we're going to look at the graph data science tool that's available in Neo4j and Aura, which I have been learning a bit in the past couple of weeks, and I hope I'll be able to show you some of the things the cool stuff that you can build together with Neo4j graph data science and the tools that we have here. So how does it sound to you?
That sounds super exciting. I mean, I've been excited from the moment you shared your first glimpse. I think at this a couple of months ago on LinkedIn when you had a short video. I think you showed, okay, this is what we're working on and this is how it looks like. And I said, whoa, this looks cool, and totally need to have a closer look at it. And then we talked and said, yeah, let's give us some time to develop this further to make it actually around and a product ready. And then now here we are. So I'm excited. I'm looking forward to this. Before I hand it back to you, I would like to invite the audience, as always, if you have questions, if you have comments to Sebastian or to myself, type it in chat. This is live, obviously, so we can answer your questions. We can go into them if there's time. If we think it's a good detour, then we can make that happen. So type it in. Otherwise, obviously, Sebastian and the channels are open. So I just linked the Sebastian's Twitter account in chat. So if you have any specific questions afterwards, you can. I'm sure you can reach out to Sebastian. If you anything as we go, any questions, any comments, any remarks, or just if you like it or not, let us know and put it in the chat so we can make it a little bit more interactive. But other than that, the floor is yours. Let's get going.
Yeah, thank you so much. And please, I do invite you to ask your questions, because I don't have any slides prepared, so that might help me with some more content. So what is it we'll be looking at today? So I got this nifty AuraDB instance that Alex provided me with, and what I'm using here is just the basic airport example. If you've been using the Graph Data Science add-on for Neo4j recently or previously, you've probably seen that tutorial. So I've just installed the AuraDB and just went through the tutorial, set up the graph. So I have a small graph in here, like 10,000 nodes, and it consists of airports and how they are connected with each other. So most of you probably know already the Neo4j Explorer here. So that's not something that we built. That's the Neo4j tool. It's great for entering Cypher queries, for playing around with ciphers and looking at the results. And there's also some visualization in here already. So there's already lots of stuff that you can do. You can connect to Bloom and use the visualization in there, and so on. What's maybe not so convenient for data scientists is that it's mostly a tool for writing Cypher queries, but not really for writing scripts. So maybe this has changed, maybe this is going to change, but as far as I know, mostly what you can do here is enter Cypher queries.
Yeah, that's not gonna change in the short term, I think. So it's I mean, that's how it came to be. Obviously, it is a visualization hook, I would say, even for Cypher queries to test out your queries, to see if everything works well, and primarily with Cypher in mind. And you can do some stuff with it with like you just said, but it's more for Cypher development workbench than anything else.
Exactly. So what you can use this interface to call the graph data science algorithms by the call statement. But as a data scientist, you typically want to or many of them want to be working with notebooks. And then, of course, one of those examples and used by many people is the Jupyter notebooks, Jupyter Labs or Jupyter notebooks. So what you do is basically do literate programming. So you mix comments with code, and then you can execute these documents. You can share these documents with your teammates, and they can re-experience or revisit your findings and let those calls basically execute live on their data. So this is not a capture. So if you share these documents with your colleagues, it's not just screenshots from your data. It's going live to the database and calculating these results. So with Neo4j, there's this Neo4j Python.
Can you zoom in a little bit to this one?
Yeah, sure.
Sebastian?
Good idea. Yeah, just a second.
Yeah, much better.
You can import the Neo4j package on the command line, and then you can access that within your Jupyter notebooks. And this is just regular Python in here. And the good thing is that you can just hit like Control Enter, and it will execute. So what I'm doing here is I'm connecting to the graph database. And the Jupyter kernel connects to the graph database, and I'm just running a very simple Cypher query on my airport graph. And this will actually allow me, this will return the result in form of a Cypher object. And it does have the ability to get a graph object. But the graph object, unfortunately, looks like this if I look at it in the Jupyter notebook. So it's not that helpful. And that's where we thought we can help with our tool. And what we did is we took our software development library yFiles, the version that works on the web, and built a plugin for Jupyter Notebook that runs the yFiles powered graph visualization right inside the notebook. And so as a developer, you will have to pip install the yFiles _Jupyter _graphs widget. You can find it on GitHub and on the PIP repositories. And I think we have some links for you to share later on. So if you want to get more details. But basically what you do after installing this is you can just like import this graph widget and then pass it the graph that you got from Neo4j directly. So this is just plain Neo4j driver executing the query, returning the graph, and I'm just creating a new widget and passing it in the graph. And once I run this, this opens this view, and now I can see the graph, the visual graph query result, pretty similar to what we have in the Neo4j browser. But in this case, it's part of my notebook, so I can basically can tell a story, and I can combine the data with other data, so it doesn't have to be all just Cypher. I could be loading data from third-party sources. So it doesn't have to be a Neo4j database, but I could be connecting to some REST APIs to collect additional data and so on. And the cool thing is, this allows me to visualize the graph results. And looking at the interface, it's quite powerful. So it's not just allowing me to, let's make it a little smaller, to zoom the graph, but I can also take a look at the properties. For example, if I hover over those elements, I get to see the various properties of the nodes, and I can also see that in this panel over here. So if I select a node, I'll see this is an airport, the Ronald Reagan Washington National Airport, and so on. So this is it's a generic tool. It doesn't really know about your graph database. We built the widget supporting Neo4j graphs, but you can also use other graph structures that you're using in memory within your Jupyter Labs notebooks. What we built in this support for Neo4j, and this enables you to browse the graph, apply different automatic layouts to highlight certain aspects in your graph, and let's check another one. So these are different layouts, and they highlight certain aspects like the structure. So we see two different layers here because all of the edges always go from the airport to the city, the region, or the continent. So we learned that there's just two layers just by looking at the graph and applying the right layout. And of course, I can also do things like, well, search for one of these elements. Airport may not a good example. What was in there? I don't know what was in there. So let's search for, well, maybe US. US. There's this country over here, and I can look at these values and inspect my graph. So it's not super useful yet, that just by looking, because it's just airport, airport, airport. Well, why is that? Well, that's the Neo4j labels that we see by default. So there's there's so many properties in there, and there's so many properties, and the tool doesn't like automatically infer which one of these to render as a label. But this is where we made this. We add this flexibility to this notebook, so you can customize the way that the graph is being visualized. So basically, the mapping from the properties in the graph database to, in this case, the labels, but also other stuff. So let me show that to you. But before I do, one more thing. Of course, there's nifty things like I can do this in full screen. So if I want to see the whole glory of my graph, I have this overview over here, and if I'm happy with the visualization, I can actually take that and export this to an external editor, which is our online graph editor, where you can actually like modify the graph, play around with it, and do other stuff like nice projections, and then export this to SVG or PDF for inclusion in some fancy PowerPoint if you want to show the results to someone. So
that's important. I mean, especially for a graph visualization, right? I mean, what good is it for you if it's rendering in a browser or in a encapsulated viewpoint? You are rendering it. I'm guessing. I mean, there are probably two reasons. One is because you want to better understand what the data structure looks like, and then you just need it maybe for yourself, or you want to show somebody else what's going on here. And if you cannot get it out somewhere, and you have to do screenshotting, is maybe not a great way, then you, it's an important feature.
Yeah, and that's the cool thing with the notebook. So you can run a certain set of queries, which, like, for example, highlight a fraud ring. So if your data has information about fraud or implicit information about fraud, you can run queries, and maybe sometimes they don't give any results because there's no fraudulent activity in your data, but you can just like keep that notebook around and just run it whenever you want to, and then once the data changes, the visualizations automatically get updated, and then you can use that and go to the CEO and say, well, there's some fraudulent activity there. So yeah. Visualization often is about like telling stories, and that's what we enable with this tool over here. But it's a boring story, as I said, so this doesn't look really great. It's really simple visualization, and so we added the ability to let the developer, or in this case the data scientist, to make simple adjustments to improve the visualization. For example, we're using data binding basically to influence the colors of the nodes, or the sizes of the nodes, or the shapes of the nodes and the edges. So while this is all the default colors over here, I wrote a little code over here. Basically, in the end, we're again showing the graph from this Cypher query above here. And what I did is I'm doing these 3 calls over here where I'm passing in some callback functionalities. And for each of the elements in the view, these functions will get called and executed, and they have an influence on the color of the edge, on the style of the node, which is things like the color, the shape, and so on. And also, I can tell it to you what I can write some code that will determine the label, the displayed label on the node. So what will be rendered on the code. So with these 3 little modifications and this nifty little tool, which basically maps Neo4j labels to a certain style schema, and also tells them what properties I want to render as a label, which I was able to do with this tool just by looking at, okay, an airport has this IATA code, and now that sounds like great code to display. So I'm adding the IATA over here, and once I execute this code, I get the graph over here, and now it has some well, not pretty, but rather meaningful colors, and I got some interesting names. So it's not just airport anymore, but it's Austin, Anchorage, and so on. So these are regions, and these are airports over here, and I can write just by giving it some color that is applied by type and specifying how to render the labels. I massively increase the usefulness of the visualization, I'd argue, because this you can actually print or put into a document and make use of it. Whereas the above, where it's just like, oh, there's lots of airports, is really useless without the interactivity. So if there's no mouse, however, that's useless. Yeah. So and now this looks a lot nicer with different layouts now, because I can easily distinguish between the different types of edges and so on. Okay, but so far this has been just like simple Cypher queries, and I promise you that we'll be looking at graph data science, and this is what this next.
Do you mind if before we do that, answer a few questions?
Yeah, sure.
So we have George ask. Okay, good. George asks, because we talked about exporting earlier, can you export the graph work with graphviz.files? Can the exported graph, sorry, I'm not good at reading apparently. Can the exported graph work with graphviz.files?
Yes and no. The exported graph, once it's in this format, you can export it to GraphML, which is an XML file, an open standard for Graph Exchange. And while this tool here can also import GraphViz files, currently it doesn't export GraphViz files. you can export to GraphML, which is an XML file, as I said, and you can also export to vector graphics, SVG, or PDFs if you want to. So if you want to have high quality graph visualizations in your publications, you should probably be looking at SVG or PDF, depending on what publishing platform you will be using. But export to GraphVis is currently not part of this thing here. However, our plugin also works great with NetworkX, which is also a Python library. So you can also just pass in NetworkX graphs. And as far as I'm aware, they have dozens and dozens of import and export functionality in there. So you might be able to reuse that. But yeah, GraphML is supported, and that works pretty well.
Yeah. Another question from Lavanya. Is it possible to visualize Neo4j's in-memory graph in the plugin? I guess this is what you're showing here, right? I mean, just to clarify, this is what you're doing.
Yeah. What really happens on a technical level is when I execute these Cypher queries, the graph is first read into the in-memory storage of the Python kernel, and then this is sent to the widget, and then it's in the browser's memory. And what we render is the graph in the browser's memory, copied from the Python memory, which was basically was loaded from the Neo4j database. Yeah. Maybe he might be referring to, or she might be referring to the graph data science in-memory graph. So where you do these projections. So we'll come to these later. Maybe that's also
could be. Yeah.
But on a technical level, this is all just passing the graph from the database to the in-memory session in the browser where it's being visualized. So this doesn't use any server active server component. So this just runs inside your browser. So I could be like running this disconnected from the internet. There's no need for an internet connection other than for the installation, and then you can just run it. So there's no server connection required. This tool is free to use and doesn't send your data anywhere because it's all handled in the browser.
Okay. And then one more question. V2 Belleville asks, if you want to pin a certain node or relationship at a certain X and Y position to, like you just said, if you have a prescripted Jupyter notebook and you say, okay, this is the main point, this is the thing that's most important, everything should start from here, or this needs to be focused or whatever. Would this be possible inside the visualization?
This would be possible. It's not implemented yet, though. Okay. We have one thing where I'm going to show in the next example is where you can use the data in the database to specify the locations on the screen. So this is one thing, but the widget itself doesn't yet have the functionality to pin an element to the graph. However, you can do this once you hit the export button and do this in YLive. You can actually do all the nifty layouts with all the hundreds of settings that we have in there, so you can get far more detailed, far more sophisticated results. But we thought that for the purpose of visualizing the data in a notebook, we didn't want to include too much interaction in there, because that's not being serialized to the document. So you would have to redo that anytime you would be rerunning the notebook. So there's some APIs that you can use in here for changing the behavior and the visualization, but the interactivity we mostly left out in the first iteration. But if you think this is something that we should be adding, please just open up an issue in the GitHub repository for this plugin, and we'll definitely consider it if it gets more votes. And yeah, please do so. This is just an early version. We just released this 2 or 3 months ago, and it's really just 0.1, and we're really looking forward to improving it. So please get your feedback going and post your issues or requests or feature requests, and then we'll see what we can do. Because under the hood, the library can do what you were asking for. It's just there's no UI in this tool over here at the moment.
That makes sense.
Okay, so
thank you.
I just like, is there another question? Or
no, that's it
for now.
Yeah.
Okay, cool.
For now, that's all good.
So I prepared this little helper function, and the cool thing is once you have this helper function and we have your default styling set up, you can just like go on and use graph data science, and then there's basically just one statement to get your graph in the way that you want it visualized for the upcoming sessions. So next topic, as I was about to explain to you, is graph data science. And this is where we have these in-memory graphs running inside the Neo4j memory for the graph data science algorithms. So I have this already prepared, and I ran this previously. So what I'm first doing, I'm just like removing this. So you wouldn't have to do this. It's just that I already have this one. So every time I rerun the script, it's first dropping this projection. But as a first step, you would be doing something like this. You would be creating this in-memory graph, and for this we also we're using the official Python bindings for the graph data science functionality from Neo4j. And so we are creating this air routes graph, and this only consists of the connections with the has route label. So what I'm doing here is I'm selecting a node. In this case, I'm looking for one airport, and this is Stuttgart, which is my closest airport. And this is actually an airport that I didn't know before, but I wanted to get something that's far away, where it requires many hops to get there. So this is somewhere in the US. I don't know. We'll see in a minute. So,
okay.
But there's no direct connection between Stuttgart and this one, because that would be a boring graph. so
that's true. Yes.
So that's why I'm using ART or whatever that is. So what I'm doing here is I'm using the one of the many different algorithms we have in GDS, and this one is just the shortest path algorithm. And I'm using the stream version of the execution of the algorithm, which means that I'm not modifying the database. And that's maybe a crucial point here, because all of the things that I'm doing here don't require me to change the graph. So as a graph data scientist, when I have to work with live data, I maybe don't want to like work on the live database and change the values. So what I'm doing here is I'm just using the power of Jupyter Notebooks to calculate the results, and then I'm using the results to drive another Neo4j query. So what I'm doing here is I let the Dijkstra algorithm run, which is a shortest path algorithm, and it will calculate the shortest path between two nodes in my graph. And I'm telling it to use the distance property, which is available in the data as a measure of, well, distance. And once I issue this call, this will be executed right in Aura on the Neo4j database instance. So not on my PC or in memory, but in the database, and it will stream back the results into my notebook. And one of the results that I get is that I get all the node IDs, basically the pointers to the nodes that make up the shortest path between my two airports. And so I came up with this little Cypher query, which is a really, well, it's basically just a long chain, which at its core has two airports which are connected by a route, and then and an airport is in a city, which is in a region, which is in a country, and I think there's also continent, but I stopped at this point. So what I'm basically loading is the information about all of the airports that are on my shortest path along with the information that's in the database, but not in the projected graph. Remember that the projected graph only consists of the airports. But when I run these algorithms, I probably want to see the nodes in context. So what I'm doing is I'm doing a regular Cypher call over here and passing it the node IDs from the first call over here. And by this, I'm creating a new graph. And then again, I'm showing that with our graph widget. So, so this is what we have here. So now let's see whether we can change this. So maybe this is more interesting to see it this way. So we have these the airports over here. For each airport, there's actually the city, the region, and the country where it's in. And we can see that obviously there's some of the airports are in the same country, in the US, and interestingly, Watertown, which is ART, is in 2 regions at the same time. Well, probably very big, very big airport.
Yeah, maybe or data problem.
I think if you search for London, London is also stored to be both in Canada and in England. So there's some problem with the data, but it's not a problem of the visualization. It's just some CSV data probably scraped from Wikipedia. I don't know. But yeah. So this doesn't very complex, but if you think about what actually happened, that's actually pretty cool. So we're using graph data science to come up with, in this case, it's a simple result. It's just a chain of nodes, but we could be using any of those powerful algorithms to come up with a result and then augment the results with the other information that we have in our graph database to come up with a, well, we can argue, but in a hopefully useless visualization. And yeah, that's it so far for this example. But Dijkstra shortest path is very simple. So there's much more complicated and more advanced graph analysis algorithms in there. So for example, PageRank. Probably many of you have heard of this before. So this is a centrality algorithm which tries to, like, from a given network, tries to find out which one of these nodes are important. So in a way, if we think about our airport graph, this is, and we have these connections between the different airports. Probably those airports which connect to other important airports or connect to many different airports are somehow more important. So I shouldn't be going to ART, but to JFK probably. And so this is what the PageRank algorithm tries to come up with. So it will basically, if I run this algorithm, it will, in this case, I'm using the mutate functionality, which updates the value in the projected in-memory graph. And then in a second step, I'm reading all those properties, the PageRank values that I wrote over here, back into a local table, which is a pandas data frame in here. And then I'm using this to drive the visualization. So so let's see whether you can have whether you can, Alex, whether you have an idea what happens here. So I'm rendering the widget over here, and well, this is pretty obvious. So I'm again showing the code for the nodes. But what is this here? What do you think this is going to be? So I'm doing, like,
you make the nodes size
according to their rank.
According to their rank, yeah, exactly. Yeah. Okay.
Yeah. So it does some extra edge cases, so I don't want the nodes to be of 0 size or infinitely large. So that's all that we're here. So I'm using, also applying a simple mapping function, because that's just Python code. I can do whatever I want in here. I could be using random numbers. I don't have to I don't have to use a linear mapping just from the data in my graph database or in my in-memory graph to the property. So I can do crazy stuff in here. So anything that will help you tell your story or get the insights more quickly is possible. So I'm scaling the nodes according to their ranks, and I'm also this probably you haven't heard of before. This is a color scheme. I haven't heard about this before, so I just copied this from Stack Overflow somewhere. So this is using some color mapping functionality from yet another from Matplotlib, which is also a graph data science tool many people use. And so this is just importing yet another library and using the functionality, in this case, to do the color mapping for the nodes. So I'm also using the ranks again for the nodes to get some nice color mapping to the nodes. And last but not least, I'm going to do that. So this one is for you. Node position mapping. What does it do? What do you think?
Well, I mean, I would have thought if we hadn't asked the question earlier that pinning at certain point was not possible. That would have been my first guess, but then you already answered that and you said that's not what it is. So I'm honestly, I don't know. Location mapping.
So this is a mapping from nodes to locations. So I think we should have some. Oh yeah, that's documentation in here. That's almost like an IDE where you can actually get a documentation. It will tell you how to use it. But yeah, I'll tell you. In the data, we actually have geo coordinates. So there, for every airport, there's a location property. So if we go back to the graph and look at the airport, let's just check the data that we have in here. So there's a location property, and it's an array of 2 values. And this is actually latitude and longitude. So these are geo coordinates. So why not use them for the placement of our nodes? Because for the importance of the different airports, I really don't need the edges. I don't want to see the connections, because there's like, I don't know, 10,000 connections in there. What I would like to see is like see the Earth and see where there's important airports. And this is what I'm doing here. So I calculate the page rank for all of the nodes. And I'm telling it to only show the more important ones, so that it's not like 10,000 nodes, but just a couple of hundreds or maybe 1,000 nodes. And then I'm just querying the graph again. But this time, I know that they have the location property available. So I'm applying the location mapping, and by returning this super complex mapping function that I came up with, I'm converting the latitude and longitude to something that looks like screen coordinates. So bear with me. This is not science. This is just, well, some values that worked well for me. So let's see what happens. So it's now going to the server, calculating the page rank, and comes back with this visualization. And that, I guess you can see what it is. So this does look like good. Europe.
Yeah.
And so we don't have a map yet as a background. So actually, it's on our roadmap to add this functionality to the widgets to really support geo coordinates out of the box, because right now what we're just doing is basically setting X and Y coordinates, but it doesn't have an understanding of these coordinates. It's just coordinates. It doesn't know that it's geo coordinates, but obviously it still works. So let's go somewhere around here. There should be this is Zurich, and this is actually Stuttgart. Yeah, and somewhere over there should also be the other airport, the
famous ART airport.
The ART?
Or ATR, I don't know.
ATR? I don't know. Maybe this one? Yeah, that's ATL. And that's probably Atlanta.
That's Atlanta. Yeah.
So probably ART wasn't in the top 1,000.
No, maybe not.
So this is Atlanta International Airport. But yeah, so this is well, it's not really a graph anymore, some would argue, because it doesn't have relationships. But well, I'm just not showing it because it's would be interesting for this purpose over here. But well, it showed us how to use the power of graph data science to get some nice visualizations.
Yeah, that's interesting. That's very cool. And then it's funny how you still see by using this, you see where things are, and you can imagine where the lines would be in this case. Yeah.
Yeah. So if you're like me, if you want to see a map in the background, well, create this issue and vote for it, because then the team is going to add this before. Because, well, it's okay, but it's just okay,
Yeah,
and we want to be better than just okay.
Yeah.
Okay, so
and I can imagine that graph data science in combination with geospatial is interesting, and then the functionality would be relevant for people.
Yeah, but as you've seen, there are some limitations to what you can do in here. So we're trying to, well, we were thinking about what is the top like 80% use cases that people have when using simple graph visualizations in your Jupyter notebooks, and that's what we came up with. So we'll be adding more features to this, but we try to make this not that much cluttered in here.
Yeah, that makes sense.
We have these separate tools that you can use to do more sophisticated edits. So that would be yLive, also free tool, and we also are planning to connect this to our DataExplorer, and this is what I was going to show you next, where we can also use graph data science.
Can we pause here for a second to answer
the question?
one or two more questions? Monkey Wrench asks, will you share the notebook afterwards, or can you share the notebook so people could access it and play with it afterwards?
I will do so. I will just have to remember to remove the database credentials. But yeah, I will do so.
Yeah, that would be nice. And then we can I can put it in the video description afterwards, and then people can click on it and play with it if they don't have their own data to do that. Is there a number, and I guess that's another question from DW, is there a number of nodes that is the max or the limit kind of for such a thing? Because if you I can imagine, and he as well said, or she as well says, too many nodes will end up with a huge mess, and then it's not I guess not meaningful anymore. But is there a technical limit?
There's a technical limit. It's not hard coded into the software. It's probably limits of your hardware. Actually, the plugin at this level is actually using WebGL for rendering. So depending, and it's really very much dependent on your GPU, on your graphics card adapter. You can actually scale this to millions of nodes. The bottleneck that you will run into first is probably if you're running one of these automatic layouts, because they typically don't have linear runtimes, meaning that they will get a lot slower for very large graphs. The visualization, there's this saying where we say the visualization is like inversely proportional. The usefulness of the visualization is like inversely proportional to the size, meaning the larger it gets, the more useless it's get. So because, well, it may look really pretty, but imagine you had like a million nodes in here with a screen which has just like a million pixels. That's pretty useless, but it would work. So there are use cases where it will work, and for this we'll be switching to WebGL, because if we zoom in this at one point, this will switch to SVG rendering, which is has this high quality rendering and more fidelity, but at lower zoom levels, this is actually switching to WebGL, and then can support many more nodes. Yeah, but I would strongly recommend trying to come up with some filtering algorithms to like reduce the number of nodes that you're going to see in the diagram. It will be way more useful this way.
Yeah.
And there's a question, well, can I like parameterize the hierarchical layout algorithm? Yes, I have this as an example. In a few minutes, we'll get to this. So bear with us. So what I was saying is that rather than just like exporting this to yLive for further visualization or export opportunities, we have plans to connect this to our DataExplorer. And our DataExplorer is also a free tool, which anyone can just run by going to yworks.com/Neo4j Explorer, which is a tool that lets you also connect to your Neo4j database. And it's actually the first tool that we built like in 2017 when we like joined the community. And it was our first thing that we basically donated to the community. And with it, you can also like connect to your database. And again, it will only directly connect your browser to the database. So don't fear of losing data. You can like basically just unplug your internet connection, and then after loading the file, and then connect to your database. And in this case, it starts with a visualization of the schema that we have in the database. And what I did in here, I marked some of the relationships as less important. We'll see why in a minute, because basically the schema that we have in this sample database is like fully connected. Like every node is connected to every other one, but some of these are just transitive relationships that I'm really not interested in. So we have like information that an airport is in a city and the city is in a region, and we also have this connection that an airport is in a region and it's in a country. So it's like multiple connections, which is great for certain types of graph data science algorithms, because we get those shortcuts. But for the visualization, sometimes it's just overwhelming. So if you look at these graphs and you click on the neighborhood of a node, and you see all these every time you see the region, the continent, and the city, and if you're just interested in the city, then that would be not so helpful. So in this tool, we can do things like specify that we don't want to see certain relationships. And once we hit the Explorer button and we take a look at the data, we see that we don't see those extra connections between, for example, a city and the region. So this is very similar to what you know from the Neo4j browser. It's just has a little stronger focus on the visualization aspect, as you can see from these hopefully nicer icons, which I downloaded from the internet illegally and came up with these nice templates. So that's the power of this visualization tool, because it's really meant to help you create more elaborate visualizations easily. So what I did is basically I have these property panel over here where I can create templates for different Neo4j labels. And if we look at these, so I can really like say, okay, I want this to be the city label over here, color, and over here, for example, there's the altitude of the airport and so on. So I get much more information right in this view. So why am I showing you this? Because this is basically an old application. However, the fact that it also supports adding Cypher queries means that I can also run graph data science algorithms. So basically, what I did in my Jupyter notebook, I can also do here. So I'm creating, at this time I'm querying Stuttgart and JFK, and I'm again calculating a shortest path. And within a single Cypher query, I'm also matching the results in here. You'll see that it's not exactly the same as we just saw in the Jupyter notebook, but very similar. So if I run this query and add these nodes, I also get this visualization. So here's the airport from Stuttgart to Atlanta to JFK, and this is in Stuttgart and New York. And we also, again, we see these visualizations over here. And so very similar to what we've seen before. Why am I showing you this? Because you asked whether you could like modify, specify where to render the nodes on the screen for the hierarchic layout. And this gets us more closely to programming. And programming is just a very small step away from this. Once we created this configuration for the various templates, I can actually take this another step forward and open yet another application that we created for you, and that is the app generator. So yet another tool. So I know your head is spinning, but stay with me. So what is this tool doing? it takes the configuration that I just created in my Neo4j browser, basically the connection settings and the query and all these templates that I like copied in here, and creates something like an ETL pipeline. So this is an application that is not solely meant to be used for the Neo4j use case. So this is really what our customers are using for like injecting their graphs into a visualization pipeline if they want to visualize graphs. So, but we have, as I told you, most of our tools also have deep integration with Neo4j. We have these Neo4j functionality. So what we see here is a pipeline. So it's basically a series of steps that will be performed mostly from the left to right in order to from get some values in the end to get a graph that I want to visualize. So that's a tool where I can like add new steps in here and connect them somehow. And this is just what the Neo4j Explorer just exported by default. And if I run this, again, let's change the color. Again, what we see here is we get the same airport graph with all the graphs. And this is, again, live, going to the database, executing the Cypher queries to render the graph. And this is
Cool.
low-code programming. So this is, you don't really have to know a lot of programming, but you can, with just a few tweaks, you can change this to make this more interactive and do the thing that you've been asking for, like constraining the automatic layout. And this is what I've done. So, Alex, try to infer from what you see here what happens. So there's some user input.
Exactly. I guess somebody puts in, I don't know what going in. Is this yeah, okay, destination. So I guess you have an input field where you say, okay, I want to go wherever, and I put in an airport there.
Exactly. So you can specify origin and destination.
And destination.
And what we do is we send this to a Neo4j Cypher query. And in this case, this is a template of the query. So it has some variables in there. So we are executing the query against some user input data. We're calling executing the shortest path algorithm on the database, and we get back the node IDs. And so the node IDs will be returned over here, and there's some IDs in this case. Well, I can't read the matrix, but these are probably 3 nodes. And what I'm doing next is this is what the output was when I exported the thing. Is basically all of this over here is I sent this as an input parameter to the next Neo4j query, and this time we're using we're passing in the node IDs. So we're looking for the airports, which we got from the graph data science results. So we're loading the graph, and then there's 5 different sources here. Those are just different. This is just a switch where we filter for the various types that we have. So if there's an airport, this looks for countries, and so this just basically dispatches to the splits the node into the different types, and then creates nodes for these. So if we run this in the end, we get this. So there's again Stuttgart, Atlanta, and New York. Okay. And now, as you can see, the cities and the region and countries are aligned in columns. Why is that? Because at the very end of the process, we run an automatic layout, and I specified a column binding. So what I'm doing here is I create a virtual grid in the output, and I tell it to like put the airports in the first column, cities in the second, region, then country, and then continents. And then depending on the label of the node, on the Neo4j label, I'm using this as the grid column. And this is what I get in the end. So this gives me this result, and just by changing the input, I get different. I get a different graph, but I got this like pre-configured visualization with the constrained automatic layout. And now you may ask, okay, but it's still not powerful enough. I want more features. I want more features. I'm a programmer. I'm a real programmer. I don't want to just like drag and drop. I want to do real source code. And that's where this button comes in, which lets you like generate from the stuff that we just did, generate an application using React and all kinds of features. And I want editing and tooltips and searching and so on. And once I click this button, this will create a zip file for me, which is source code. Now I can just like, let's open it. It's over here. And this is source code. And when I open this in my IDE, I can execute it. And first I have to install it. So this is a web application. And when I run this, I have this prepared. I happen to have this prepared. So this is the source that the application created. So this is no modification in here. I just opened it in my IDE.
Yeah.
And then I can run npm serve, and this will compile my files into a web application. In this case, it's using Vue. It's not React with TypeScript, so it needs some compilation. And then it hosts my application, and here it is. And it asks me for the. Now let's do something else. Another one, LAX. LAX to Stuttgart. Now it's going back to the database, calculating the shortest path, then running the automatic layout and coming up with this nice visualization. Not great, but nice visualization. But so now I have an application. Now I can pass this to my team, and they can integrate this into a dashboard, or create an application for it, or host it on the web, or whatever. So that's like using graph data science to create an application. Is that cool?
That's very cool, and it's very easy. So I mean, you click this together in a couple of seconds now. I mean, obviously, this is a small demo, but and it can get more complicated and it takes a bit longer. But this shows the way, and it's it's pretty cool.
Yeah. And now for those developers, this is only the start, because if you look at about the many demos and features that we have on our website that show what you can do with our library, you basically can take some of these features and say, okay, this is something that the app generator doesn't allow me to do, because we haven't created a user experience for all of those features in the app generator. But this is also source code, so you can just like take a look at an example, go to GitHub, or take a local copy of the source code and merge the two features into one. And just to show you what this could be, I had this other example. Let's just stop the first one. Stop the server. So I modified this example over here and just changed the way the nodes are visualized. So really, like, I think it's really like 50 lines of code, and copied 15 lines of code, and I copied over a source file from one of our demos. And now we have this visualization. It's the same graph again. But now we're using this cool isometric view, and we have these bars over here. I think I mapped them to the altitude of the airport. So that's one of the information that came to my mind that was available in the data set. Yeah. So augmenting the visualization with more features, adding more interactivity, like being able to search nodes and or STR, and then highlight the corresponding ones and so on. Of course, as a developer, there's basically no limits for you. You can do all those stuff. I see we're a bit over time, or are we?
We are a little bit, but
I think at this point I should stop.
That's not a problem. We had a couple of questions as well, so I guess that counts. And it was a great demo. It was super insightful. I mean, I didn't know about this app builder, so I learned something new as well. Which is pretty cool, and yes, you just showed very, very quick and easy. So I guess to sum it up, people if they want to know more and want to try it out themselves, best way to start is, I guess, go to yworks.com and use one of the demos to try it out themselves. I will put a couple of links in the video description. I will put the video, the link to this actual notebook we use, or Sebastian showed here earlier, into the link to it as well, so you can try this specific one. But I saw on your landing page for the yFiles graphs for Jupyter, you have sample projects linked as well, with sample notebooks on GitHub. So I guess there is a lot of content already for people to try and to give it a spin, or just use your own data, right? I mean, the tool is, as Sebastian said, free. So I think that's the big takeaway. Try it and use it and play with it and give feedback to Sebastian and his team.
Yeah, exactly. Please do so. And not even a sign up is required. You can use all those tools I shown you, apart from if you want to do the software development for free and without any sign up. So just go to our website and launch them and play around with them. And please do send us your feedback. So that's really important to us. We're working on a round of new features, and I hope Alex will invite me for another chat, maybe somewhere around, November, December. I hope we'll be done with all the new features in our DataExplorer for Neo4j at that time. And so, but your feedback matters, and it really helps us focus on the features that you need.
Yeah, I'm sure we can talk again in the future. So that was great today. Maybe because it's important, DW just asks, can we use yFiles graphs for commercial applications? So I mean, maybe you wanna highlight that a little bit for commercial projects.
Yeah, the tools that I shown you today, you can use in any context. So in an academic or commercial or private context, they are all free to use. The library itself is a commercial library, but if you're using these tools, you're only indirectly using the library. So we built this application. If you want to build your own application, really with the help of the software development kit, this is a commercial license, and then of course you can use it in commercial or whatever context. The tools you can use today, now, whatever context it is used in, as long as you don't like reverse engineer it, then I'm going to be like this. But yeah, no, those are all free tools and for you to use, and do use them in commercial context. Yeah, no problem.
Okay, cool. Well, that's easy then. Thank you very much again, Sebastian, for the demo, for your time, for the presentation. That was very, very fun and good to see, for me at least. I think the audience agrees. I have a couple of wonderful visualization toolbox. Applause, great tool. Thanks for the demo. Great visualization. All good comments. So yeah, I think that was good. We should do it again. So definitely towards end of year or beginning of next, when new features are available, let's maybe do another episode. Until then, thank you all for watching. Thank you for sticking around and for making it fun and interactive. And we'll see you next time. Actually, next week is a kind of break week, so I think the next Neo4j Live will be in 2 weeks' time. Tune in then, or catch up with previous episodes in the meantime. Thank you, and see you soon. Bye.
Thank you. Bye-bye. It was a pleasure.